So we've got our moons of Saturn here. We're going to be looking at these today. Just like Jupiter, Saturn has a lot of moons. I think Jupiter actually has more. But just to give you an idea of how many there are, yeah. So, I mean, I kind of had to pick between having you memorize all of them or just focusing on a few and looking at those, and that's what we're going to do. How do I know which ones to pick? I don't know. That's a good question. Well, that's just for ease of the picture, I think. They're not always on one side of the planet. Titan is one of them we're going to look at. Yep. So, as far as this slide goes, go ahead and write down bullet point 1. You actually probably should do everything. You can skip the last dash though. You don't have to know that they had snakes for legs and were born fully armored. I know labor is painful, but I can't imagine it would be like bearing a child that is born fully armored.
That'd be awesome.
So in Roman mythology, Saturn was the leader of the Titans here, and eventually they were overthrown by the Olympians, led by Jupiter, or Zeus is his Greek counterpart there, and there was that big war that happened. So, because Saturn was the leader of the Titans, all of Saturn's moons are named after various Titans, as you'll see. So, okay, Mimas is the first one we're going to look at. Write down Mimas. And that it's the first relevant moon from Saturn. There are others that are much smaller that are closer. This is the only one that actually looks kind of like a moon. So, it's the first relevant moon from Saturn. In terms of the history here, you don't have to write this down, but Mimas perished in the War of the Titans by a volley of molten iron. That is like the manliest way to go out, I think, by being killed by molten iron. Mimas is very, very small. You don't have to write this diameter down, but it is a really, really small place. You can write down what it's made up of, though. Surface, it is cratered and icy with a little bit of rock. You can write that down. This is really, whoever made this picture, this is not a real image, whoever made this picture really did their homework, because this is about how big Saturn would look if you're standing on Mimas. That would be quite a view, huh? Almost looks like you could reach out and just touch one of Saturn's rings there. This one's not quite as accurate. Saturn would look much bigger than this. But this does a pretty good job representing what the surface might look like if you're standing there. You've got rocks, you've got some ice. This is the map of the surface of Mimas. And if you look at this, you can see one feature that sticks out more than all the rest. Whereabouts is it? Yeah, the giant crater on the left. And there's a special name for this crater. It is called Herschel crater. Write down, you don't have to write down how big it is, but write down Herschel crater. Also write down that Mimas is the smallest astronomical body with a round shape. Just irregular. They look like big rocks. And just like when we look at Saturn from Earth, its rings are tilted in different ways based on what season it is. And same thing if you're standing on Mimas, how you would see Saturn is going to be different based on what Saturn is looking like in its orbit around the Sun. So this could be a possible view too. It'd be really cool to just stand on Mimas and see something like this. Another image right there. This is really good because this is a pretty good description of how big the Sun would be from this distance. It would still be very bright. Like I mentioned, it would still hurt your eyes if you stared at it, but it's starting to lose its disk shape now that we're this far away. Some people have drawn the comparison from Mimas to the Death Star.
Oh, yeah. Wow. Wow. Even though I don't know what the Death Star is to you.
The interesting thing is, we didn't see Mimas until after Star Wars came out, so this is all just, they didn't look at Mimas and say, let's make the Death Star. It was all by chance. I don't know, actually. I'm not sure how big the Death Star is. Sounds good. Yeah, Mimas is 200 or 300 miles across, so. The other thing that's interesting about Mimas, and it's kind of funny because Mimas, how much? 100 miles? Okay. So the Death Star is about half the size of Mimas then. The other interesting thing about Mimas is it doesn't just look like the Death Star, but when you look at a picture of it that describes how warm it is and its temperature, obviously the side that's facing the Sun would be hotter than the side that isn't. And when you take a thermal image of Mimas, you get something like this. which of course looks like Pac-Man eating the dot there. The only thing that Pac-Man would be missing in this case, you've got your space Pac-Man, and you'd be missing a space ghost. Anybody familiar with Space Ghost at all? Rob, a little bit. He was a semi-popular superhero in the 60s. What was more popular was the talk show that he hosted in the 90s. If you get a chance, look up Space Ghost Coast to Coast on YouTube. It's a hoot. I think it's hilarious. I liked it back then, and I still think it's pretty funny. You might ask, how can a cartoon interview people? And basically what they would do is they would interview people in a studio, and then they would form the show around different answers that person said. And they totally took everything out of context and made it real funny. So it was a cool show. Enceladus is the second relevant moon that we're going to look at here. So Enceladus is a really, really neat place, and it's actually very cool in a lot of different ways, but I do apologize for the mythology behind Enceladus. He is known as the trumpeter to arms. You can see how he was born. We're just going to let that go. And he was killed by Minerva's spear in that big war between the Olympians and the Titans. So we're going to quickly move on to the next slide. About 300 miles across. So in general, one thing you can see is that the moons of Saturn are much smaller than the moons of Jupiter. The moons of Jupiter were usually maybe 2,000 or 3,000 miles across. Saturn, we're looking at much smaller moons. You can write down the surface. The most interesting thing about Enceladus is probably why everything is not just so cold and icy, but why there's so little rock. It's mostly just ice. If you land on Enceladus with a pair of skates, you're going to have a blast because the surface is pretty much all iced over, and you're going to see why that is shortly. Here's a map of Enceladus' surface. You can see very few craters. You got some, but mostly this is all just flatness right here. And you can go ahead and write down this entire slide. Yeah, basically. Not necessarily, for a reason that you're going to see soon here. That's a good point, though. If it all just escaped into space and went away, it would kind of start to get hollowed out. But most of this does fall back to the surface, and you'll see why in the next slide here. So as far as Enceladus goes, it is the most reflective surface in the entire solar system. Most of the light that hits Enceladus is reflected back by a long shot, more than anything else in the entire solar system. The reason for that is because of all the cryovolcanoes that Enceladus has. It erupts water and other things from the inside of the moon, so you're not going to be dealing with lava or sulfur like on Io or something like that. It's especially active at the South Pole. Most does fall back to Enceladus, but some of it goes into space. And you can see the result of that right here. Enceladus shoots off so much of this material that you can see the ring of Enceladus' orbit as it goes around Saturn. So it's constantly running into this material that it's ejected on a previous pass around Saturn. And that's why its surface is constantly being resurfaced. It's always running into that material that it ejected not that long ago. And these are so powerful that you can see them occurring from a long ways away. I mean, even though Enceladus is pretty small, I mean, this is being launched, looks like between 50 and 100 miles in the air. And when you've got a world that is so small like Enceladus, you're not going to have as much gravity. And so it's much easier for that material to leave Enceladus and remain in orbit around Saturn. Another picture right there. This is an artistic representation. You really would not want to be next to this stuff if you're skating around Enceladus. If you're skating around and you see this eruption occurring, and you like put your hand in there, your hand is going to get blown off. That's how fast it's going up. So you want to make sure you steer clear of this material if you are going to skate around on the surface of Enceladus. A couple more pictures. And essentially this is what's going on. With Io on Jupiter, remember that Io was pulled in a couple different directions. It was pulled by Jupiter, and it was pulled by Europa, the next moon out. And that constant pulling, that constant tugging, is what kept the interior really, really hot and molten. And that's why Io had so many volcanoes and sulfuric activity. Enceladus is kind of the same thing. It's heated by this activity, and when you have that interior that's really, really hot, all that high pressure wants to find an escape route, and eventually it gets so hot that it does. If it doesn't find a route, it just blows a hole right through the surface. And that's what you're constantly dealing with on the surface of Enceladus. Titan! We're going to spend most of our time on Titan here. So several things that we need to know about Titan. You can skip this slide, but it's named after the race of Titans. It's the most massive moon of Saturn by far, so they didn't name it after a specific Titan. Size is 3,200 miles across, so this is real, real big. It is rocky and it is icy. And this is an artistic picture of the sort of thing you'd see if you descended to the surface of Titan. You can see there's this liquid here. This is not water. This is actually liquid ethane. Yeah, no, it is not fun. And I'll have you write more about that in a second here. Another kind of neat picture right here. You can see again, yeah, the sun is much smaller. That's about how big Saturn would look. Yeah, we can look at that for a little bit. Well, we could, but its atmosphere has a lot of nitrogen and it has a lot of methane. And it has a lot of methane rain in it too. What do you know about methane? It smells real bad. So we don't want to go on the surface of Titan because it's going to smell awful. So you die in a lot of other ways, but you know. So the other thing too, when we do use sonar pictures to see the surface of Titan, there's this dark brown stuff there. They call that Shangri-La, and they're still not quite sure exactly what it is. Here's your little map. From this slide, go ahead and write down everything. And so you can see pretty quickly why Titan is such an important moon. This is one of the 2 moons in the solar system that NASA really is focusing on trying to send missions to. The first is Europa, because of all that ice and the water that might be below it. But Titan has its own special place because it has a stable atmosphere. It's the only moon in the solar system with one. And its atmosphere has different weather and has different features. It's not just a thick atmosphere like Venus or something. You've got wind, you've got rain, you've got sand dunes, rivers, lakes, seas, shorelines. You wouldn't last very long there, but it does have all these different features, which is the sort of thing we'd like to study more. So you've got wind and methane rain, which of course, as I mentioned, would not be a pleasant smell. The other thing about Titan is that it does have actual liquid, stable liquid on its surface, but it's not water, it's ethane. It's primarily near the poles. You don't need to write this down, but you can see on the map here, these are some of the locations that they have of these ethane lakes. So it'd be kind of neat to drop a satellite with a camera on it and take pictures of some of these alien shorelines from Titan. And this is a sonar mapping of those ethane lakes. You can write this one down too. So you can see pretty clearly why having rivers with very little erosion and not having many craters, that obviously points to something that's young, because if it was older, you'd see those features very prominently. But one of the big surprises they found is based on the atmosphere of Titan, they expected to find a moon-wide ethane ocean. They thought the entire thing would be covered in liquid ethane. They were very surprised to see that there's a lot more land than there is water, or that there is liquid, I should say, liquid ethane, because some of the measurements they took of the atmosphere, if it had been around for millions or billions of years, they would have expected that rain to form an ocean that covers the entire place, not just localized areas. Iapetus, or I don't know how you pronounce this. I've actually never bothered to look it up. It might be Iapetus or Iapetus, I don't know. But it's the fourth relevant moon from Saturn, and it's the last one we'll be looking at today.
What if the I is pronounced like a Y?
It could be Iapetus. That'd be a fun one. Or maybe this is actually an L, and I've just been getting this wrong the whole time. Sounds good. So when I look at Iapetus, it looks to me, you can kind of see the little ridge here. It almost looks like a little bit of a nut. And so I thought I'd throw in a picture of a squirrel. Why not? So, known as the piercer, that was Iapetus. Okay, good to know. Iapetus was known as the piercer, and the sun of Uranus, which we'll be talking about soon. This is a larger moon, almost 1,000 miles across, but not as big as the moons of Jupiter. The surface is cratered and icy with a little rock. You can skip this. That's about how big Saturn would look from this distance. So now we're considerably further away than the other moons.
Is the mouse on the moon or the moon?
Yes, that is a mouse on the moon. And that's not mine, actually. That was in the image. Yes. There's your map of Iapetus. You bet we are. The giant crater is called Englier Crater. You can write that down. You don't need to put the size in there, just the crater. Looks like someone just kind of hit it with a big snowball. Yeah. Yeah, that's actually, nobody really knows. Yep. There's that little equatorial ridge. You can write this down too. So we've got that pretty prominent equatorial ridge there. It does follow the equator almost perfectly, and nobody even has a theory as to how or why it's there. But it is. If you find yourself on a moon that has a ridge that goes around the entire moon, you know you're on Iapetus. The other interesting thing about Iapetus, you saw from the image of Saturn, that it is much further away than the other moons that we've talked about up to this point. It also has an extremely large inclination orbit. So you're going to want to write this down too. In blue, you see the orbits of some of Saturn's other large moons. Now, with all these moons of Saturn, most of them are real small. None of them are more than 1,000 miles across, aside from Titan. So, a couple interesting things about this. The only thing I need you to write down from this slide is Titan. Can we see it from Earth? Yes, with binoculars or a telescope. So just Titan, that's the only one you need to write down for this. So yeah, Titan is the only moon of Saturn that you can actually see without a telescope. You just need a good pair of binoculars and you'll be able to pick it right out. It looks like a real small star next to Saturn. And if you look at Saturn through a telescope, kind of like in the back of the room there, this is the sort of thing you'll see. Of course, this is going to be Titan right there. And you can see some of the other moons. This would be kind of an ideal scenario where Saturn is tilted in such a way that you can really see those rings. It's not always that nice, but... And there's your family portrait. Quiz on the moons of Saturn tomorrow. I don't know. I'll have to look.